Good day, guys. Welcome to the channel. If you're new to my channel, please like, subscribe, and hit the share button. Okay. So, guys, today we are going to deal with Newton's laws. Okay. So, Newton's laws, we deal with forces, and you might need to know some basics about vectors. Okay. So now, what do we need to know about Newton's laws? Okay. So, with Newton's laws, according to your metric, you are going to learn about four of these. Four of these uh, laws. Okay. Now, the first one, we call it Newton's first law. Newton's. Okay. We call it Newton's first law of motion. All right. Now, this law talks about an absent force. Okay. No forces. Okay. That's how I want to force my student to know about this law. So, what does this law say? And under normal circumstances or in everyday life, where do we see this this law applicable? Okay. Now, take an example of a car. If a car moves at the constant speed of 60 kilometers per hour to the right, all right. So now this car is moving at a constant speed, or the bus moves at a constant speed of 60 kilometers per hour towards the right. Then suddenly the bus stops. Okay. Now its speed is 0 kilometers per hour. Okay. Now when the bus suddenly stops, what will happen to the passengers? The passengers will keep on moving at this speed. Okay. So now that's why car manufacturing companies decided to create what we call the safety belt. Okay. Because now, if you need to brake the car immediately, or emergency braking, you need to stop the car from 0, for example, from 0 kilometers per hour towards from 60 kilometers per hour to 0 kilometers per hour. Now the passenger and the driver will keep on this velocity of 60 kilometers per hour unless there will be a force stopping the two bodies. Okay. Now that force will be applied by the seat belt. Okay. Now, knowing this concept, what does Newton's first law of motion says? Now, in simple words, this law says objects like to keep on doing what they're doing unless you change them otherwise. Okay. If an object is moving, it wants to keep on moving. If it is stationary, it wants to keep on being stationary. Okay. So that is the simplification of Newton's first law. But now, how are you supposed to write it in your examination question paper? Now, it states like an object will remain in a state of rest now this is when the object is stationary. Okay. Or continue okay, traveling it's a double L, traveling at a constant speed. An object will remain in a state of rest or continue traveling at a constant speed unless, okay, now let me highlight this part, okay, okay, now unless acted upon you upon by a net force. Okay, now this law applies where there is no force. An object will remain in a state of rest or continue traveling at the constant velocity. Other book says uniform motion, okay, unless acted upon by a net force. So this object will keep on doing whatever it is doing, whether at rest or moving at a constant velocity, as long as the force is absent. Now, if the force is present, what will happen? Okay, now that will lead us to Newton's second law of motion. Okay, now what does he say in second law of motion? Okay, now in a presence of a force, let me take it to 2. Okay, now second law. Second law of motion. Okay, now the force is present. Okay, there is force present. Now what is happening when there is a force? All right, now if you are pushing a bicycle, the bicycle is just standing there, or maybe a car. A car is just standing there, okay, or a buggy, and you are applying a force to that direction. Okay, now where do you think the car will go? Will it go up? Will it go down towards the direction of the force, or in the reverse? Okay, so definitely the car will move towards the direction of the force applied. Okay, now this is what Newton's second law of motion is describing, that if you apply a force on this object, it will cause this particular object to accelerate in the direction of that force you applied. Okay, now if you keep on applying more force, what will happen? The acceleration will also increase. Okay, now but if you keep on applying the same force but you increase the mass, you will notice that the acceleration will kind of decrease. So that acceleration will be directly proportional to the force, because when you increase the force, the acceleration also increases, but if you increase the mass, it decreases. So you need to state that. Okay, now let us put it in weights. Okay, now putting in weights, what do we have to say about Newton's second law of motion? Now, an object, if a force is applied on an object, okay, let me change the pen. Okay, if a force is applied on an object, is a T. If a net force is applied on an object, okay, now if a net force is applied on an object, it will cause the object to, now this is a keyword, accelerate. Okay, it will cause the object to accelerate in the direction of the force. Okay, now acceleration is directly proportional to the force and inversely proportional to mass. Okay, now sometimes in an exam you are lucky enough they give you 3 points, 2 points for describing it and a mark for saying acceleration is directly proportional to the force and inversely proportional to the mass. Okay, now this is Newton's second law of motion. Okay, now what does Newton's third law say? Because there is a third law. All right, now Newton's third law, I will make an example of an object that is on top of a table. Okay, there's a table and there is a box standing somewhere there. Okay, now this box, there is a contact force, we call it the normal force, that will be there. Then there will be an Fg. Okay, now these two forces are equal to one another. All right, now we call it an action reaction pair. All right, so on a third law, Newton's third law, we say it's a action reaction pair. Why do we call it an action reaction pair? Because now when a box exerts weight on top of this table, the table exerts the same force that is equal in magnitude but in the opposite direction, and we call it the normal force. Okay, now if you push a wall, as long as that wall is not moving, the wall will exert the same force that is equal in magnitude. Magnitude, we're referring to the value of the force, but in the opposite direction. That's why you are balanced. So if these two forces were not the same, this box was supposed to crack the table and fall downwards. Because if one force is greater then the resultant force is not equals to 0, then the object has to be accelerating in a certain direction or moving in a certain direction. I hope that one makes sense. Okay, now how do we state Newton's third law of motion in words? Okay, now to state Newton's third law of motion in words, you will need to say it moved a little bit. Okay, now how do we state a third law of motion in words? No, let me rub. Okay, now to state it in words, where's that pen? If body A exerts a force, okay, on body B, that is a statement. If body A exerts a force on body B, what will happen? Then body B will exert the same force of equal magnitude, will exert the force of equal magnitude, on body A. Okay, now this is straightforward. If body A exerts a force on body B, then body B will exert the force of equal magnitude on body A. But there is a condition. But in the opposite direction. Okay, now this is Newton's third law of motion. All right, now there is the last one that we need to solve. Okay, we call it Newton's law of universal gravitation. All right, so guys, Newton is quite a genius. He created a lot of things. Also, if you study in calculus, you'll realize that Newton's is there. Okay, so we also have a Newton's law of universal gravitation. All right. Okay, now what does Newton's law of universal gravitation say? Now there is a history on how this guy created this law, but I don't want to dwell on it. Okay, but in English there is a say that says an apple doesn't fall far from a tree. All right, Newton's discovered this law using that particular apple. Okay, so this law says every point mass attracts every other point mass by a force directed along the line connecting the two. All right, meaning a radius between the two. Okay, now the force is proportional to the masses, meaning the product of the masses. Okay, and inversely proportional to the squared distance between them. So I will draw an example. What does this law say? So now if we've got an orange there, even though it's black, and we also have another orange there, so this law says these two oranges attract each other, okay, attract each other. I'm sorry, this line is not straight. It says the force connecting these two, all right, attract the two masses, okay, by a force equal to what? The product of their masses. So it's mass of orange 1, mass of orange 2, and inversely proportional to what? To the squared distance in between them. Alright. Now there is a constant, of course, that will make sure that this law holds everywhere, and that constant is capital letter G. Alright. Now this is Newton's law of universal gravitation. When mass 1 attracts any other mass in the universe with the force equals to the product of their masses and inversely proportional to what? The squared distance in between them. Alright? So let's see how we write it in words. Okay. It says every point mass it may be planets, oranges, or apple, okay, attracts every other point mass. Attracts every other point mass by a force okay by a force along a line connecting the two. Okay, now this is a statement on its own, it's finished, but now you need to state the condition. So this force we are talking about, all right, is proportional this force is proportional to the product of the masses okay, directly proportional to the product of the masses and inversely proportional to the squared distance. In between them. Okay, now this is Newton's law of universal gravitation. All right, now let us try to put these laws into good use. All right, okay, let me see. I want to add a picture here. Yes. Now we have a situation here. All right. I want us to try and keep these laws into good use. Okay. Now I'm going to use this question paper to answer and describe other concepts that we need to solve in this particular topic. Okay. Now please feel free to shoot a pic, and so that when I describe, you can have a pic on your phone and be watching. All right. But let me try doing something. Okay. I managed to put this question into our document. All right. Now this is the question. Okay. Let us try solving and see what is what. Now it says a block of mass 4 kg is connected to another block of 2 kg by a light inextensible string. Okay. Now a light inextensible string means a string that doesn't stretch. It's like inextendable. Okay. Now the system is pulled up a rough plane inclined at 30 degrees to the horizontal. Okay. That's angle of elevation by means of a constant force of 73.8 newtons parallel to the plane. Alright, as shown in the diagram below. Now the magnitude of the kinetic frictional force on the 4 kg block is 20 newtons. The coefficient of kinetic frictional force applicable to the 2 kg block is 0.589. Okay, the coefficient, so if it's a coefficient, it doesn't have units. Now describe the concept frictional force. Now what is friction? So guys, when you talk about the frictional force, we are talking about a force that opposes motion. All right. When we talk about frictional force, we are talking about a force that opposes motion. Now it doesn't oppose the applied force, it opposes motion. I want to stress on this. Now if you have a car, let me restart this line. Now if you have a car or a box sliding down a plane, okay, this box is going into that direction and you want to stop it, you apply a force into that particular direction. You are attempting to stop this, but still, even with your efforts, the box continues to slide downwards. Okay, now the applied force is going upwards, but in this kind of scenario, the frictional force will also go upwards. Why? Because this box is moving towards down. You understand? So the frictional force doesn't oppose force applied. Instead, it opposes motion. Okay. Now, if they are asking you to describe frictional force, how will you answer it? Just like in 2.1. 2.1. Frictional force. It is a force. Let me remove you. That opposes motion, and it acts parallel to the surface. To the surface. Okay, it is a force that opposes motion and it acts parallel to the surface. All right, that is frictional force. We have two kinds of these forces. We have no, that is a definition on its own. You don't need to state this, but I just want to let you know that we have two kinds of forces under frictional force. We have the static friction okay. The static friction, we normally symbolize it as Fs. It applies to stationary objects. Okay. Then we have a kinetic. Frictional force. Okay. We normally symbolize it with Fk. Alright. Now, under normal circumstances where we are talking about the same surface and the same object, the static friction is slightly greater than the kinetic frictional force. If you want to push a car, it is harder to start the car to move than to get a car that is moving and push it. Alright? Now, that's what I mean when I say the static frictional force is slightly greater than the kinetic frictional force. Okay, now let's go to this one. I just stated earlier the Newton's second law of motion in weight. It says when a net force is applied on an object, it will cause the object to accelerate in the direction of the force. That is your 2 marks. The remaining mark on these 3 marks, you need to state that acceleration is directly proportional to the force and inversely proportional to the mass. Okay, I'm not going to write it this time around because of time. Alright, now that is Newton's second law of motion. Now 2.3, they want us to draw a free body diagram with labels showing all forces acting on the 4 kg block. Okay, with labels showing all forces acting on a 4 kg block. Okay. As it moves up the incline, please be mindful of the following. These are important key things that you must note. You may not include components of forces. Those of you who like to draw FG parallel and FG perpendicular instead of FG, they are restricting you from doing that this time around. You may not use numbers as labels. Okay. If you disregard these 2 statements, it is wrong. Now the question is 2.3. Okay, now a free body diagram, you need to take note that this is on an inclined plane. Okay, this is on an inclined plane at an angle of 30 degrees like this. Okay, just want to show how you might need to draw. Then you need to make your dot. It is not necessary for you to show the incline, guys. Okay, it's just to make it easier for everyone to see how you get to all forces. Now there are 2 obvious forces that you must put before other forces. One of them is the gravitational force, Fg, and remember they said you may not use numbers. Alright, so this is Fg. Then you also have the normal force. The normal force is a force that is perpendicular to the surface. Alright, so even if it's not perfect, but it needs to do some kind of 90 degrees. We have this force, which is Fn, the normal force. So now these will always be there. Now we have an applied force and they restricted us from using the numbers, so we need to show that this is an applied force. Okay, So we have a force applied. Now it's 5 marks. This tells you that you need 5 forces. We have 2 forces in the downwards direction. One of them is tension, the other one is the kinetic frictional force. Because why? They said it's a rough surface or a rough plane here. Can you see that? Now we have this force that goes there, which is the tension. We have another force, which is the Fr or Fk. Okay, Fk for kinetic frictional force. Now these are all your 5 forces. All right, each force gets a mark for 5 marks. You understand? So, and you need to show the correct angles, not especially to show 30 degrees, but Fa must be parallel to tension and Fr because they are acting on the same plane. Fn must be normal or at 90 degrees to Fa to tension and to Fk. Then this one must be going straight downwards. All right, that you must show. Now 2.4, calculate the magnitude of the kinetic frictional force on the 2 kg block. Okay. Now there is a trick here that you must know. Okay, let me wrap this question, this answer now. Since you have drawn it, or pause, you can rewind the video to see. Okay, now under normal circumstances, when you calculate the kinetic frictional force, or we can say the static frictional force, so your force in this case, it's kinetic, will be equals to mu k multiplied by the normal. Okay, this is when it's on a flat surface. The kinetic frictional force is the coefficient of friction multiplied by the normal force. All right, now in this case we have an inclined plane, so we need to put the angle, the cosine of an angle, so it will be the cosine of theta. This is a formula that you need to put in this regard because of an inclined surface. On a flat, it will be mu k multiplied by the normal, then it is good enough in that regard. But because it's an inclined plane, the cosine of theta, it is necessary. Okay, now Fk will be equals to mu. They gave us the kinetic frictional force as 0,589. All right, multiplied by the normal. Normal is mass times gravity. Okay, so mass is 2 times 9,8. The cosine of what? The inclination angle, which is 30 degrees. When you calculate in physics, make sure that your calculator is in degrees, not radians. If it's in radians, you are going to get a wrong. All right, now what is the answer here? Let me check my calculator. Okay, we've got what's that calculator kit here? I will be using calculator on my phone. It's 0,589. So 0,589 times 2 times 9,8, the cosine of 30 in degrees. Okay. All right. So I hope I chose the correct units. Is it really this one? All right. Now I'm getting 10 newtons. I'm getting 10 newtons. All right. If you get any other option, you guys will correct me. All right. Now 2.5. Calculate the tension in the string that connects the two blocks. All right. Now I want us to pay attention towards this question, guys. All right. When you want to calculate the tension, it will need a simultaneous equation. First things first. Now, this is the importance of mathematics in physics. So we got 10 newtons here. We will note it. So here we got 10 newtons. All right. Now, for us to calculate the tension, we need to create equations for both blocks, for the 4 kg block and for the 2 kg block. All right. Now, in these equations, you are going to have two unknowns, but it's fine. I will explain when I get there. For the 4 kg block, okay, let me, okay, they gave us, it's here, I was looking for this frictional force. They gave us a 20. All right. Now for the 4 kg block, first things first, you write your equation. F net equals to ma. All right. Now, what is the net force composes of? If you go back towards our free body diagram, okay, I will draw one here. The forces that we have on the 4 kg block is this normal, it is this tension, okay. Now there are other forces. Obviously there is kinetic frictional force and another force which is G parallel, okay, that is the component of gravity. Now the applied force is the only force that goes to the right, which makes it have a different sign in the equation. I'm going to start with it. This is force applied. So since all other forces are going to the opposite direction, I'll put a negative before them. So minus tension minus Fk minus Fg parallel, which is equals to M times A. All right. Now, if you go back to your statement, I want you guys to realize something, guys. They said they are being pulled by a constant force here, meaning that F force final minus force initial, they are the same, then there is no acceleration. Okay. That's just the concept behind the constant force. All right. Or what I can see is that the acceleration of this block and the acceleration of the other block is the same. Now let us substitute values. The force applied in this case, we have 73.8 minus the tension. We are looking for that. So let me do this so that I can just easily highlight tension. So minus tension okay, minus, on the 4 kg block we're given the kinetic frictional force of 20, okay, minus G parallel. So G parallel, it's mg, the sine of theta. So m, which is 4 multiplied by the gravity, which is 9,8, the sine of 30 is equals to 4a. This is the equation here. All right. Now, I'm sorry about this. Now, this gives us 18,87. 87 minus tension is equals to 4a. Okay. I want to make a subject of the formula, so 18,87 minus t all over 4 is equals to a, and I will call this equation 1. Alright, now let us move. Now looking at the 2 kg block, what will be the free body diagram? There's a tension. In this case, tension is positive, G parallel is negative, and kinetic frictional force is also negative. Okay, now I will say for 2 kg block, this is the forces, I mean. Okay, we are going to have a tension minus Fg parallel minus Fk, which is equals to Ma. Now when we substitute tension, we don't know it, minus this is 2 times 9,8, the sine of 30, minus we calculated the force earlier, which is 10, which is equals to 2a. Alright, now let me check this force. Okay, what was that? I think I made a mistake up there. Let me verify. I think I used a cos instead of a sine. 73,8 minus 20 minus 4 times 9,8, the sine of 30. Yes. If I didn't miss anything again, this is supposed to be 36. Okay. Please guys, the calculator that I'm using is very old. Make sure you also verify from your site. 36,0035, so I'll say 3 there. Alright, okay, now this one, it is 2 times 9,8, the sine of 30, okay, minus 10, okay, let me do this, delete, okay, plus 10. Now this gives us t minus 18,898, okay, divided by 2 equals to A. Now this is equals to A and that is also equals to A. Now we are allowed to equate the two equation. Okay, I'm going to equate this and that. This here, I hope you can see up there and here. Now let me write it down there with the red thing. So T minus 18,898 over 2 will be equals to 36, okay, minus T over 4. Alright, from here I'm going to multiply it by 4 both sides to eliminate fractions, né? So I'm going to have 2t when I multiply it by 4 both sides. Okay, I'm going to do multiply by 4 everywhere. Now I'm going to have 2t minus this times 2, so it will be minus 30. Okay, I was using a red pen. Minus 37,79, which is equals to 36 minus t. Alright, now t comes this side, this goes there, so 3t is equals to 37,79 plus 36, which is equals to 73,796 wada. Now divide by 3 both sides. Okay, when I divide 3 everywhere, t gives me 24,598 newtons because it's a force. Okay, now that is the answer on question 2.5. okay, now I will give you guys to do question 2.6, but wait, let me check my load shedding schedule because I don't want time to cut. Alright, it's almost 2 o'clock. Let me see. Alright, lucky enough we still have time. Okay, yes, lucky enough we still have time. Now they say the system is pulled up through a rough incline once more, but this time the 2 blocks are swapped. Okay, meaning the 2 kg block goes at the top and the 4 kg block goes at the bottom. Okay, choose your answer as decrease, remains the same, and increase. 2.6.1, the acceleration of the 2 kg block. Now my dude, I said this is an inextensible string, meaning that the acceleration of the system is the same for both blocks. Okay, now the acceleration will remain the same for everything because the force did not change. Okay, now 2.6.2, the force of friction of the 4 kg block. The mass is still the same, the surface is still the same, so the force of friction does not change. Okay, now what will be the tension in the steering? Okay, the tension in the steering will increase. Why? Because the block that has more mass is at the bottom, is being dragged, not pulled by the force. So as the force with more mass is being dragged, there is more tension in the steering. It's like a light car towing a truck. There will be more tension in the steering than a truck towing the car. I hope you guys understand that one. So the tension will increase in the last question. So if you have questions, please comment at the bottom. And if you're happy, subscribe to the channel for more content in physical sciences. Cheers, guys.